Dear students, today we are going to discuss exercise 1.3 questions from the book. Before we begin the exercise, first of all, let's understand two types of numbers which we generally discuss. One is rational number and another is irrational numbers. You have studied in your lower classes also that rational numbers are numbers which can be expressed in P by Q form, where Q should not be equals to 0. So the numbers like 2 by 3, fractional numbers or decimal numbers, they can be expressed in P by Q form. Similarly, whole numbers, we can write them also in P by Q form. For example, 5 is a whole number, it can be written in as 5 by 1. But there are some numbers which we cannot express in P by Q form. They are called irrational numbers. So today we are going to discuss about them. So let's have a look at some irrational numbers. Here some numbers are written: root 2, root 3, root 5, 2 root 5, 3 plus root 7. These are some examples of irrational numbers, since we cannot write them in P by Q form. You can see that we cannot solve their roots. So such numbers are called irrational numbers. Now we will learn in this exercise that how can we prove that these numbers are irrational. And let's start. So first we have a question: prove that root 5 is irrational. One thing we have learned so far is that irrational numbers, they cannot be written in P by Q form. We cannot write them like this. Now we have to prove that root 5 cannot be written as P by Q form. So we want to prove it irrational. But first of all, we will assume that root 5 is rational. We will assume it rational, and then at the end we will try to prove that it is irrational. So first of all, let us assume that root 5 is rational. If root 5 is rational number, then we know each rational number can be written as P by Q, or we can take any two alphabets, P by Q, or we can take A upon B, whatever you want to write. So we have supposed root 5 as rational, so we can write root 5 as A upon B, where B should not be equals to 0. So first of all, we are considering it rational, and at the end we will try to show that it is irrational. Now we can take this B to the other side, so it will get multiplied with root 5. So we will get root 5B equals to A. Then we will square both the sides. So we will write squaring both sides. So when we do square on both the sides, this will give us A square, and here we will do root 5B square. So root 5 square will be 5B square. Now we have got this equation. Now what do we see in this? We see that A square equals to 5B square. So this shows that we can say that 5 divides A square. Here we have taken root 5 as A upon B, and here A and B we have to take co-prime. Here we can add this also, that A and B are co-prime. Co-prime means they don't have any common factor. Their HCF is 1. Now this equation shows that 5 divides A square. We know if 5 divides A square, then there is a property that if any prime number divides square of any number, then it will also divide that number. So 5 will divide B also. 5 divides A. So what we can say, if 5 divides A square, 5 divides A, it shows that 5 is a factor of A. So we can write A equals to 5C. We know when some number divides any other number. For example, we have a number, say A, 5 divides it. Then there will be some quotient here. Suppose that quotient is C. So, and it completely divides, remainder is 0. Then we know dividend is equals to quotient into divisor. So we can write A equals to 5C. Suppose we take this number as 25. If this number is 25, or we can take it 30. Now we know 5 6 are 30. So we can write 30 equals to 5 into 6. Similarly here we are not taking 30. We don't know what is the value of A. So we are simply taking 5 as a divides A. So we can write A equals to 5C, because if 5 divides A, it means when we divide A by 5, it will be completely divisible. Then there will be some quotient. We are taking that quotient C. So we can write A equals to 5C. So now we will put this value of A equals to 5C in this equation. In this equation we will put A equals to 5C. So what do we get if we put A equals to 5C in this equation? In place of A I am writing 5C whole square equals to 5B square. Now 5 square is 25, C square equals to 5B square. This 5 will cancel with this. So we will get 5C square equals to B square. Now we can write it in other way also. B square is equals to 5C square. Now what do we understand from this statement? Here we see that B square is equals to 5 into C square. So this shows 5 divides B square. So we can write 5 divides B square. If 5 divides B square, then this implies that 5 divides B also. If 5 divides B, and in previous case we have seen that 5 divides A also. So it means 5 divides both A and B. 5 divides A as well as B. It means 5 is a common divisor of both, common factor of both. So both A and B. It means A and B are not co-prime. Means 5 is a common factor of both A and B. It means A and B are not co-prime. But what we assumed in the beginning? In the beginning we assumed that A and B are co-prime. That's why we have written root 5 equals to A upon B, where A and B are co-prime. It means what we assumed is wrong. We assumed they are not co-prime, but we proved that they are co-prime. It means our assumption is wrong. What we assumed in the beginning is wrong. What else we assumed in the beginning? We assumed in the beginning that root 5 is rational. It means this is also wrong. Root 5 is irrational. So our assumption is wrong, and we can say that root 5 is irrational. So how you have to perform this question in the exam if it comes? They will ask you to prove root 5 is irrational, but first you will assume it rational, and you will choose, you will write it as root 5 equals to A upon B, where B is not equals to 0 and A, B are co-prime. Then you will take this B to this side, then squaring both sides. Then you will say from this equation we can say 5 divides A square, so 5 divides A. So A can be written as 5C, and then we will put this value, and we will get these steps, and we will show 5 divides B also. So 5 is a common factor of A and B. So we prove that A and B are not co-prime. So our assumption is wrong and root 5 is irrational. So in this way we can show that root 5 is an irrational number. So you have to write all these steps and do this proof. So with this proof we come to know that root 5 is irrational number. Now let's try another example. Here we want to prove that 3 plus 2 root 5 is irrational. Now from previous proof we have learned that root 5 is irrational number. Now we want to prove this as irrational. Now first of all, again we will assume, let us assume that 3 plus 2 root 5 is rational. So whatever we want to prove irrational, in the beginning we will assume them rational. Now if it is rational, it can be written in P by Q form or A by B, anything you can take. So I have taken A upon B because in most of the books they have used these symbols, these alphabets. So we can take this B to this side, it will get multiplied with this. Okay, first what we do, we don't take this B here, this 3 you remove. What you need to do, you need to keep this root 5 alone. We have to separate this from other numbers. So all these numbers we will take to the right side. So first of all this 3 will go here, we will be left with 2 root 5 equals to A upon B. This 3 will go to the right side and get subtracted, minus 3. Now here we can take LCM, nothing is below 3, so we will take LCM. We will get B and here we will get A minus, this B will get multiplied with 3, A minus 3B. Now we want to separate root 5, so this 2 also we need to remove. So we will take this also to the right side, it will go down and get multiplied with B. We will get root 5 equals to A minus 3B upon 2B. Now what do we understand from this equation? From this we see that root 5 can be written as you can see the root 5 can be written in P by Q form. Now you know A, B, what we have taken in the beginning, again they are integers, they are co-prime integers. Okay, so when we subtract them and when we write them in A minus 3B upon 2B, so when we solve integers, we know that when we add, multiply or subtract anything from them, again we get some integers only. So root 5 is shown here in P by Q form, or you can say rational number form. So what we can say, that the right side shows rational number, but we know root 5 is irrational. So how can a rational side be equal to an irrational number? So these both sides cannot be equal, they are giving different result. This is a rational form and this is irrational number. We have proved in the previous proof also. It means what we got is wrong. This is a wrong statement. It means what we assumed in the beginning is wrong. This is not rational, this is irrational. So we will write our assumption is wrong. What we assumed in the beginning, that 3 plus 2 root 5 is rational, but by choosing it as rational number, we have come to a conclusion at the end which doesn't satisfy the condition. So we will say 3 plus 2 root 5 is irrational. We can write 3 plus 2 root 5 is irrational. Now from this result, what do we understand? That a very important result comes into picture, that if there are rational numbers like this root 2, root 3, root 5, root 7, anything, and if we multiply something with them, then the resulting number is again irrational. If we multiply or if we add something in an irrational number, or if we subtract something, or if we divide something with an irrational number, then the resulting numbers are again irrational. Here what we did, we had a number, irrational number root 5, we have multiplied 2 with it and then we added 3 in that. So whenever we do some changes, we add, subtract, multiply or divide something with the rational number, then the resulting number is again irrational number. So we can prove similar questions using this result. So let's try one more. Here we want to prove that 1 by root 2 is irrational. Now we know 1 is a rational number, but root 2 is irrational. So when we divide a rational number with irrational number, then also the resulting result is irrational. Now how we are going to prove it? So the steps for the proof are same. First of all, we will assume that 1 by root 2 is rational. If it is rational, then how can we write it? We can write it in a by b form, where a and b are co-prime integers. We need to mention these conditions, that when we are writing them, a and b are co-prime integers and b should not be equals to 0. Now we can cross multiply them. We will get b equals to a root 2, or we can bring this a down. So we will get b upon a equals to root 2, or we can also write it as root 2 equals to b upon a. Now from this equation, what do we understand? B upon a is a rational number form and root 2 is irrational. We already know, we have seen that all these type of numbers, we have proved that they are irrational. Now this is irrational, but this is rational. So the two results are opposing. We know root 2 is irrational number, and this form b upon a is just like p by q form. This shows a rational number. So this is a contradiction. This statement is wrong. We can't have a rational number equals to irrational number. This is not possible. It means what we assumed in the beginning is wrong. Our assumption is wrong. So again we will write the same steps. Our assumption is wrong. Or first we can write this contradicts the fact. This statement. Which statement? Let's write that statement once again. We got this step at the end, that root 2 equals to b upon a. So we will write this contradicts the fact. What is the fact? We know the fact is root 2 is irrational, but b upon a is rational. So both can't be equal. So this contradicts the fact. So our assumption is wrong. What we assumed in the beginning, that 1 by root 2 is rational, it means 1 by root 2 is irrational. So with all these proofs what we have done today, in the beginning we have assumed that number as rational and written it in form of a by b, where a and b are co-prime integers, b shouldn't be 0. Then we have shown a result at the end which contradicts the real fact. So we come to the conclusion that our assumptions which we assumed in the beginning of these proofs were wrong. So 1 by root 2 is irrational. So students, in this chapter in this exercise you get questions based on proving the irrational number. So all the proofs you need to write like this. So you must practice how to write those steps. First understand the concept and then practice more examples of such type from book. Thank you. If any doubts, feel free to ask. Thank you for watching.